In this video, I want to talk about one-sided limits and do an example to help us understand them just a little bit better. Here I have our step function, or a step function that is, and I could easily tell you that the limit as x approaches 3 of g of x does not exist. Right, because on this side it looks like the y values are all going to 1, and on this side it looks like the y values are all going to 2. That was one of our quintessential examples of when a limit didn't exist. But right in saying why it doesn't exist, I have this idea that on the left-hand side, if my x's were coming from the left, it looks like there is a limit. Or if I was only looking at that side and covered it up, it would look like the limit's 1. I do the same thing coming from the right, it looks like the limit would be 2. And that's my notion of a one-sided limit, that I could say the limit from the left. And the way I annotate that is x is going to be approaching 3 from the left. And we use a little minus in the exponent spot to say from the left. And we do that because the negative numbers are to the left. And in a minute we're going to talk about from the right, where the positive numbers live, and that'll be with a plus. Another way to say it is the x values that are close to 3 but on the left-hand side of it are a little bit less. They're 3 minus something, right? They're over here. And so what I would write for this problem is the limit as x approaches 3 from the left is 1. A limit from the right we write down as an x approaches 3 and a little more, right? Because I'm on this side of it, those are 3 plus something. Also the positive numbers are over there on the right. And I would write that for this function, the limit as x approaches 3 from the right of g of x is 2. Okay, so I want to do an example in a minute, but this leads us to an important theorem. Theorem 6 in your textbook. Suppose that a function f is defined on an open interval containing c, except perhaps at c itself. Then f of x has a limit as x approaches c, if and only if it has left-hand and right-hand limits there, and these one-sided limits are the same. And the way I like to think about this theorem is written right down here, so I'm going to write that on my board. If I have a function, I'm going to call it f this time. If that function has the two-sided limit, the limit we defined first, I'm going to call a two-sided limit. The limit as x approaches c of f of x is L. And we saw that double implication. We read that as an if and only if, but it means this statement implies what I'm getting ready to write down, and the thing I'm getting ready to write down implies that one. The two-sided limit is equal to L if and only if the two one-sided limits from the left and from the right match and are both also L. This limit exists if and only if these two one-sided limits are the same. Said another way, if these two one-sided limits are different, then this limit does not exist, which is exactly what we set up here. It's different from the left and different on the right. So from now on, if I want to tell you why this limit doesn't exist, I'm going to write down the two one-sided limits. The two-sided limit does not exist because these two limits are different. All right, so now let's do that example where we get a little more practice with one-sided limits. I have a function graphed here, and I'm asked to find the following limits or explain why they do not exist. In the first one, I'm asked to find the limit as x approaches 0 from the right-hand side of f of x. Well, as my x values get close to 0 from the right-hand side, it looks like my y values are getting close to 1. If I was asked to do this limit from the left-hand side, I'd have to tell you it doesn't exist because those x's aren't even in the domain. The limit as x approaches 1. Well, I got two different things going on. This does not exist, and to explain why, now I'm going to write down two one-sided limits. And this is what we'll do from now on. The limit from the left of f of x looks like it's 1, 2, And from the right, the limit as x approaches 1 from the right, looks like it's 1. Because these two limits are different, that limit does not exist. And that's the best way of writing down why. My two one-sided limits are different. That also tells me there's a step there, right? There's a jump. And now I'm just asked to evaluate the limit as x approaches 3 from the left of f of x. All right, 1, 2, 3. Nothing really interesting here. From the left, everything's going to 1. Let's do one more. The limit as x approaches 4 from the left. Well, as I approach 4 from the left, all of my x's are still getting close to 1. All right, that's what we need to know right now about one-sided limits. In the next video, we're going to get a deeper understanding of how to handle limits that have a sine of theta over theta as theta approaches 0 in there.